Welcome to The Explainer. Today we're diving into something called the Model Context Protocol, or MCP for short. Now, this is the tech that lets an AI actually do things in the real world. Use tools, interact with systems. But, and this is a big but, with all that power comes some pretty serious security risks. So today, we're going to break down exactly what those are, and more importantly, how to handle them.
All right, so here's the plan. We'll kick things off with the basics, what MCP is and how it actually functions. Then we're going to get into the juicy stuff, the three main areas where things can go wrong. We're talking risks in the code itself, from user input, and from third parties. And finally, we'll pull it all together and look at how to keep your system safe.
All right, first up, what exactly is this protocol? What's the big deal that's promising to make our AI so much more connected to the world? Okay, so the easiest way to think about MCP is it's like a universal translator or a bridge. It's the set of rules that lets a large language model understand a command you give it in plain English, something like, hey, email my team the latest report, and then actually connect to an external tool like your email client and do it. It's what turns the AI's thoughts into real-world actions. Now, this is a really important distinction to make. You've got two main ways to set this up. You can run these MCP servers locally, on a machine you control. This gives you total power, but guess what? It also means you're on the hook for every single risk, or you can use a remote server run by a third party. This can feel safer because you're offloading some of that risk, but now you have to trust someone else with your data. It's a classic security trade-off, and you really have to think about which one makes sense for you.
So let's get into the nitty-gritty. How does this whole bridge thing actually work? When you ask the AI to do something, what's happening behind the scenes?
Okay, it's basically this six-step dance between you, the client, the AI model, and the server. It starts with you making a request. The client then talks to the LLM saying, hey, here's what the user wants, and here are the tools we have. What should we do? The LLM figures it out and says, use this tool with these parameters. The client then passes that instruction to the MCP server, which does the actual work. The server sends the result back to the client, which hands it back to the LLM. And finally, the LLM crafts that final response for you. It's a whole conversation happening in milliseconds.
So, that's the happy path, right? When everything works perfectly. But where can it all go wrong? Well, let's start with our first danger zone, vulnerabilities that might be hiding right there in the code you write.
Yeah, this is every developer's worst nightmare. Because those local MCP servers can execute any code, they are a massive target for something called command injection. What that means is, if you're not super careful about how you handle data that a user gives you, an attacker could sneak in their own commands and trick your server into running them. Not good.
And look at this. This little snippet of code is a perfect example of the danger. It's supposed to just pop up a desktop notification. Simple, right? But see that variable, alert title? If an attacker can control what goes into that variable, say by crafting a malicious input, they could potentially inject all sorts of nasty commands, turning a harmless alert into a full-blown server compromise.
So, how do you defend against this? The number one rule is trust nothing. You have to treat every single piece of user input as potentially hostile. Sanitize it, clean it, check it. But you know what the real best practice is? Run the whole MCP server in a sandbox. Think of it like a padded room. Even if an attacker does manage to break something, they're trapped inside that room and can't do any real damage to the rest of your system.
Okay, so securing your own code is one thing, but the risks don't stop there. The danger can actually come from the prompts your users are typing in.
This one's really sneaky. It's called prompt injection. Imagine a user finds a super helpful prompt on some website and pastes it into your application. But hidden within that seemingly innocent text are instructions that basically hijack the AI. It could trick the model into leaking private information, deleting files, or maybe even creating a new user account for the attacker. It's a tough one. The takeaway here is absolutely crucial. Do not give the AI full control. Never let it have complete autonomy over sensitive actions. You always need to keep a human in the loop. Before the system does something big, like deleting a database or sending a critical email, it has to stop and ask the user, hey, are you sure you want me to do this? That simple confirmation step is probably your single best defense against prompt injection.
All right, so we've covered securing our own code and being wary of user prompts. But what about the code we didn't write? Let's talk about the dangers that pop up when we start relying on tools and servers built by other people.
This is basically a classic bait and switch. So you might find a handy little third-party tool that says it checks the weather, looks totally harmless, you install it, and it works great. But then, one day, the developer pushes an update. On the outside, everything looks the same name, same description, but on the inside, they've secretly added code to slurp up your confidential data and send it back to their servers. The tool you trusted has turned against you.
So how do you stop that? Simple. Don't trust automatic updates blindly. You have to lock down the exact version of the tool that you've already checked and know is safe. In the developer world, we call this version pinning. It means your system will only use, say, version 1.2.3 of that weather tool, and it won't upgrade to 1.2.4 until you've personally reviewed it and given it the all clear.
And this brings us to the bigger picture, supply chain risk. This is a massive problem in all of software today. Think about it like this. Your MCP tool is just one brick in a giant wall. But that brick is built on top of other bricks, the libraries and dependencies it uses. And those are built on even more bricks. If just one of those tiny foundational bricks way down at the bottom has a crack in it, a vulnerability, then your entire wall is at risk of collapsing.
Look, securing your supply chain is just not optional anymore. You have to be vigilant. This means running automated scanners, tools like SAST and SCA, on everything you build. They'll hunt for known vulnerabilities in all those little bricks. And you need to use digital signatures to make absolutely sure that the code you're about to run is the exact same code that the developer published, with no malicious tampering in between.
Now, this one is really clever and kind of scary. The MCP protocol actually allows a remote server to ask your AI for help completing a task. A malicious server can totally abuse this. They could just spam your system with thousands of these requests to run up a gigantic bill on your API account. Or even worse, they could craft these requests to try and trick your AI into doing something you never ever wanted it to do. The only way to fight this is to give the user absolute control. You simply cannot give a remote server a blank check to use your AI. Your application has to show the user every single one of these sampling requests. Give them a big red no button. And on top of that, you need hard limits, rate limits to prevent spam, and cost controls to make sure you don't wake up to a 5-figure bill. It's all about putting up guardrails.
All right, we've gone through a lot of scary stuff. Risks in the code, risks from users, risks from third parties. So let's pull all of this together. How do we build a defense strategy that's actually proactive?
It really comes down to 3 key pillars. First, authentication and authorization. You have to make sure every single action is performed with the user's explicit permission. This stops what's called the confused deputy problem, where a bad guy tricks your powerful but naive system into doing its dirty work. Second, logging. Log everything. If something suspicious happens, you'll need that trail of breadcrumbs to figure out what went wrong. And third, good old-fashioned vulnerability management. You have to treat your MCP clients and servers like any other piece of critical software. That means scanning them regularly and keeping them updated.
And you know, this quote from the research really hits the nail on the head. We're giving AI more and more power, more agency to act on its own. And that's exciting. But we have to acknowledge that this comes with a whole new set of security risks. We can't just stumble into this future. We have to be really deliberate and proactive about building it securely.
So this all leaves us with a pretty big question, doesn't it? As AI gets more and more capable of acting in the world, as we build these amazing, powerful bridges, how do we make sure they're bridges we can actually trust? What will it really take for us to feel safe with these incredibly powerful systems we're creating?